Hello everyone. In this video, I'm going to talk about a Solidity programming language which we'll be using to write smart contracts on the Ethereum blockchain. Before starting, I'd like to quickly introduce myself. I'm Amrisha Kakoti and I'm working as a software engineer at Kpro Solutions Private Limited. Kpro is a leading provider in Datalake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are what's a function, modifiers, and finally state mutability functions, that is view and pure functions. Let us start with what is functions. So we have seen how function works or how we define and declare functions in our previous examples. So we have used functions a lot. So now let us see these functions in a little bit more in detail. So functions helps us in creating transactions and implementing custom logic. They accept parameters and return values. The parameters passed in the functions change execution of functions and provides multiple execution paths. They accept multiple parameters with identifiers uniquely named. So this is all about functions. Now let us see what are the different ways by which we can declare a function. So the first one is we can declare a function with a single input parameter returning a single value, which we'll do in somewhat like this. The second one is multiple input parameter and returning a single value. Third one is single input parameter and multiple return value. And the fourth one is single input parameter and returning a value as tuple. Now let us see how we declare all these things or how these kind of functions work in an example. So this is a simple example of declaring different types of functions in a contract. So here the first function is taking one input value and returning one value. That is addition of the value passed with itself. The second one is taking two values and returning one value. The third one is taking one value and returning two values. And the fourth one is taking one value and returning the values as a tuple. So let me deploy this and see what do they return. So the first one is single input output. That is this one. So I'll just give the value as 6. And in the console we'll have the value. That is 12. So 6 plus 6, it's returning 12. Next is it is taking two values and returning one, right? So multi this one. So I'll give 2 and 3, for example. So it should return 5. Okay. We deploy this and here you can see it is returning 5. The third one is taking one value and returning 2. That is this one. So I'll just give 3 and it should turn 3 plus 1 4 and 3 into 2 6. 4 and 6. It's returning 4 and 6. And the fourth one is taking one input value and it's returning the value as a tuple. So I'll just give 2 and it's returning, it should return 2 into 2 4 and 2 plus 2 4 4 4. Yeah, it's returning 4 4. So these are the different ways by which we can declare functions. So this is all about functions. Now let me go back to my slides. Now let us talk about modifiers. So modifiers helps modifying the behavior of a function. The code remains the same but the execution path changes. Modifiers can only be applied to functions. Modifiers are defined using the modifier keyword followed by an identifier, and within the curly braces we'll have the code or the logic. The purpose of modifier is to replace itself within the target function code. And modifier helps in writing cleaner, more readable and more maintainable code. Now let us have a look at an example of modifier. So this is a simple example where I have used modifier. So here in this is the contract. So here we have this state variables, that is a of type uint, and I have assigned 5 to it, and I have a variable b of address of the type address, where I'm storing this message.sender, which is nothing but the address which deploys the contract. And here this is the modifier. This modifier is simply saying that if this message.sender equals to B, so if the address is the one that has deployed the contract, then execute the target function. And this is the target function. So here you can see this is how we write the modifier. So this modifier is related to this function set A. So what this modifier is simply doing here is that it's executing the function only if the address from which the function is executed is the one that has deployed the contract. Now, okay, whatever I have been blabbering now, let me just quickly show you with the help of by deploying this contract. So I'll simply deploy it. And you can see I deployed the contract using this address, okay? Whatever this address, I'm not touching it. So, and I am again setting this value using this address itself. I'm not changing it. So let me open the console. And here you can see the value should get, yeah, it's giving me 67. That is, it's returning the value that is set. Now so I have deployed the contract once, so I'm not going to redeploy the contract, but instead I'm just changing the address to something else, and I'm trying to modify call this function. So for example 56 set A. So now here you can see it's returning 0. This means since this condition is not satisfying here, hence this function didn't get executed. So this is basically what the modifier does. Next, let us talk about view and pure functions. So these view and pure functions are known as state mutability attributes. These functions primarily helps in updating or reading state variables and executing logic. View functions just return values without state modifications. View functions are also known as constant functions. So in the previous versions of the Solidity compiler, we could use the constant keyword and the view keyword interchangeably. But from the compiler version, I think 0.4.75, this constant keyword has been deprecated, and instead of that, we will be using the view keyword. And pure functions are more restrictive in terms of state mutability. Pure functions do not allow reading and writing to global state. So basically, view functions can access the storage state, that is the state variables, but cannot modify them. But the pure functions cannot even access those state variables. Now let us understand these functions with the help of an example. So this is an example where I have used the view function here. So what did I say about view function? I said that the view functions can access the state variables, but they cannot modify it. So here I have this. So this first function, let's see what this first function is doing. So this first function is simply returning the state variable. It is not making any modifications to it. So according to the definition, this function should work. Let's see. Yep, no error. And let me just try to deploy it. And value, yes, it's working fine. Next, let me again comment this up. Next, let us see this function. So what is this function doing? So this function is modifying the state variable, that is incrementing and it's storing, right? So according to definition, this function should not work. Here you can see, yes, we have an error here. So this function will not work. So the view function cannot make modifications to the state variable or to the blockchain in general. Sorry. Yeah. Next, let us see this function. So what is this function doing? So this function has no access. It's not accessing the state variables, but instead it is just passing a value, and it's just returning the value multiplied by 5. So this function should work totally fine because it is not accessing the state variable in any way. So yes, I'll deploy it, and here you can see I'll just 78. Yeah, 390. 78 into 5 is 390. So this is what the view function does. So it cannot access the state variable. It can access the state variable, but it cannot make modifications to it. And this function works because this function is not accessing the state variable in any way. So this is all about the view functions. Now let us see the same contract using the pure function. So here, this is the same contract. Okay, I'll come to this. Yeah. So here again, we have this state variable. And what did I tell you about the pure function is that these pure functions cannot even access the state variable. So it is similar to the view functions, only restrictive in the sense that it cannot access the state variables. So according to the definition here, it is returning the state variable, value of the state variable. So according to the definition, this shouldn't work. Let's see. Yep, it's giving us error. So a view function cannot access the state variable. Next, let us see what is this function doing. It is making modifications to the state variable. Obviously, this will not work because it cannot even access the state variable. So yes, it's not working. And what is this function? When this function has nothing to do with the state variable, it's just taking an input value and it's just returning the value multiplied by 5. So it should work fine. Yep, it's working fine. So I'll just deploy it and show you. Here you can see. Yeah, it's working fine. So this is all about the view and the pure functions. Now let me go back to my slides. Now let us have a quick recap of the topics that we have covered in this video. In the beginning, we talked about functions. Then we talked about the different types of function declarations. Then we talked about modifiers. And finally, we talked about the view and the pure functions. Thank you for watching this video. In the next video, that is Introduction to Solidity Part 12, the topics I'll be covering are address functions, the send method, transfer method, call method, delegate call method, and finally the fallback function. Kindly provide your valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in your project. You may write to us at feedback@kpro.co.in. You can also subscribe to our channel if you want to learn more about technologies like blockchain, cloud, data science, ETL, data lake, DevOps, big data testing, cloud testing, etc. And you can also follow us on YouTube, Facebook, LinkedIn, Twitter. Thank you very much. Let's keep learning.